Okay. Okay, let's look at the assignments for today. All right. So just make sure that we understand what each assignment needs, and I'll go over a little bit more than I did last week because, I mean, not write more code, but what's expected, what the inputs, what the outputs are, because of that issue with the first one from last week, right? I used the wrong word basically. Said write a function, I'm going to write a program. So this one is going to ask you to write a simple function or functions. I don't care if you put them all in the same function or not. What I'm trying to say. Takes a list of numbers and does the following. So we need either a series of functions or a single function that first checks the list and see if it is a list of just numbers. In other words, if there's something in the list that's not a number, it needs to know about it. It needs to tell you that it's not a list of numbers. So, if they are all numbers, then we need to have a function that returns the sum. We need to have a function that returns the mean, and a function that returns the standard deviation. Okay? You can write this as 3 separate functions, or you can write them all into the same function. I think it's a little bit easier to put them in the same function because you need to calculate the sum to get the mean, and you need to calculate the mean to get the standard deviation. So, but you could just have it return the sum, and then in the mean function, you could just get the mean. It'd be a really short function because it would just be the output of this function divided by the length of the list. And then this is probably the one that we need to talk about because not everybody probably understands how to calculate the standard deviation. Okay? All right, and then this one is written correctly. Test this function above by creating a program to generate a report of the return values. So all I'm talking about there is you need to create a program that prints out the sum, the mean, and the standard deviation. Okay? You don't even have to ask the user for it. You just prove that your function or functions work by printing out the mean, standard deviation, the sum, the mean, and the standard deviation. Everybody knows what the sum is. It's the total of all of the values in the list. Everybody should know what the mean is. We already calculated that. In fact, we could pull that up as the start of our thing. Yeah. You know, something that I totally glossed over, that I forgot to look at was tuples. Okay. It'll take me like 2 minutes to tell you about what a tuple is. A tuple is almost like a list, except for the elements are not mutable. They're immutable. Okay? So tuples are immutable. And then the only other thing about tuples that's useful, well, not the only other thing, but the other thing that is useful is that tuples, you can actually use tuples in assignment. So if a value returns and list, and you know that list is going to be 2 items long, you can actually set it equal to a value like you could do something like this. Well, I'll just show you. You could say A comma B, this is what I was getting at before, is equal to 1 comma 2. So as long as your tuples are of equal size on either side of the list, you can do this in Python. So B is equal to 2. It's the second element. A tuple is, you could also say Z is equal to 1 comma 2. Now if I print Z, a tuple is like a list, but it has, instead of square brackets, it has regular parentheses. But only when it's shown to you. You don't need the regular parentheses to define a tuple. You can put them in there, but they're not necessary. So D is equal to, I.
So would we be doing something like tuple equals sum, comma, mean, comma, standard deviation, and it'll print it out in parentheses separated by a comma?
Yeah, so if you want to return multiple items out of your function, like if you write a function that returns the sum, the mean, and the standard deviation, it could just be, you could write return sum, comma, mean, comma, standard deviation. And then your output is actually a tuple. And a tuple is the same as a list. So the output, bracket, bracket, 0 is the sum. The mean is the standard deviation. I mean, the mean is 1. This is element 1, 2, and 3 if you wanted it to be element 1, 2, and 3. Okay? So you can actually return multiple numbers out in a return statement. They're just really only one thing. They're a tuple. Or you could return them as a list. Let's actually write that one real quick, because we already wrote the mean, right? This is the mean. Which one is the mean? Find the mean right there. Yep. So I'm just going to delete. So I've still got my find mean function here. And I'm going to call this, I'm going to save this as Raber George 31 underscore 2018. Now this is one of the ones I did change slightly. So the previous version of this won't be the exact right answer. So I changed this one slightly. I made it a little bit easier. This function, I mean this exercise. All right. So ours isn't just about finding the mean. Ours is just, let's call it stats, because we're going to find the sum, the mean, and the standard deviation, and we're going to find out if all the numbers are in fact numbers. Okay. So that's actually first. So let's write that. Find out if all values are numbers. If not, return none. So that's what we need to do first. And in fact, we could use a try statement and just do that at the same time. But let's just not do that. Let's just do a for statement for val in my list, because we don't even know if they're numbers, right? So we're going to check through and see if each value is a number. Let's just see if there's an existing Python function to find out if something's a number. What's that? Yeah, that's the way I was going to write it. If it equals integer or float, then it's all good, right? There is a isNumeric function which will check and see if a number is numeric, but that's actually not what we want. So let's do what I thought I was going to do originally, which is exactly what you said. If type val equals int. Oh yeah, thank you. And then or type val equal float. Right? So what we're saying is,
Extra closed bracket on your first value.
okay, yeah, but I just closed it as you were talking, sorry, you're right. Sometimes I like to put the whole thing in. I don't think it's necessary in Python, but I have, I think everything closes up right. No, you're right.
You got extra right behind the first val.
Type val.
Yeah, well,
Or that. If you're missing one or you got an extra, I don't know.
around now,
This one is where I'm missing one. You're right. Exactly. And then I need, well, this closes this closes that closes this. You see how this closes this?
yep.
This closes that, but I don't actually need it right here. Or type val, and then that closes it. That's correct. I'm pretty sure. Because now this one closes that one. See what I mean? And then these two close each other, and those two close each other. All right.
Could be or inside, like you couldn't do that just as one function, like type val equals, and then and or close.
No, not in Python. So what you're saying is, could you just do this kind of thing?
Yeah.
No, you can't. It's just a limitation. I mean, there might be other languages where that's possible, where it understands that you want that, but you have to retype it.
But just in general, like you would put an operator inside. Like that, right? You can always do it twice.
Yes, you have to put it twice. And so then we can just write return none, because, oh wait, that's actually the good stuff, right? Yeah, so we can either modify this like that, or this is Python. So we could negate it, because once we hit this, what happens?
Okay, what?
We return a return statement.
So,
Yeah, it kills the function. So if it hits this, it's going to return none. If not, it's going to continue down here and do what we want it to do, calculate the mean. So that should work. I need to write the rest of this up to make sure that it works right. Let's
is, print find means, you know, change back to stat.
Yep. Yeah, let's see if this runs. So now if I run this, I get 32.333. That's right. So that's the mean. Okay. Now what if I put in I and we'll try to run it? It returns none. So it's doing the right thing. So now here I'm going to say calculate the stats and return. Okay. All right. So right now I'm returning the mean, but I also want to return the total, right? The sum is the total. So how can I modify this return statement to also return the total using what I just told you about tuples? Yeah. So now it's going to return a tuple with tot and then mean. So now if I run this, oops, I need to take off the high because that's not right anymore. Oops. Now if I run this, I'm going to get a tuple, and it's giving me the sum as the first one, and it's giving me the mean as the second value. The sum and the mean. Okay? So the only thing I need to do to change this up, there's two things I need to do. I need to calculate the standard deviation and return that too. Okay? And then I need to make it look like a report. So I need to say the standard deviation, or sorry, the sum is this, the standard deviation is this, and the sum, the mean, and the standard deviation. I need to report each individually, so the user doesn't just see these numbers. Okay, those are the only things I need to do. So, calculating the standard deviation. Anybody have a? Well, it's the square root of the variance, but how do I calculate the variance? Do you remember?
Got it written on an index card somewhere at the house.
Yeah.
Let's refresh our memories.
You have to follow the deviations first.
Yeah, well, we need all the deviations. What's a deviation?
Difference from the mean.
The difference from the mean. So we need, for each one, we need the difference between the number and the mean. But we don't even have the mean till we're through the loop once. So calculating the standard deviation actually requires us to loop through again. But we need the mean with us this time. So let's inject our code down here, and this is where we're going to calculate standard deviation. And here is here's the formula. We're going to take we're going to find all the deviations. Okay, and we need to square those. Could do that at the same time. Add them together, and then divide by total. Okay, so that's what we need to do. We need to find all the deviations, and the deviations are just the observations minus the mean, or the mean minus the observations. Since we're going to square them, it really doesn't matter which order of operations, because they're all going to be positive after we do the squaring. And then we need to add them together. So we need to basically create a running total again, and then divide by the total. Let's just say by n again, by the number. All right, so I'm just going to copy this formula that's already there, okay, because it's not going to be much different, except for this time, our total is going to be different. We're not interested in just a running total. We're interested in the deviations. So the deviation is actually calculated as the number minus the mean, right? So here, our number minus the mean will give us the difference from the mean. And next we need to square them. How do we square this number?
For math.
Yeah. Yeah, we could do that. We did talk about that notation on the first day, right? It's been a little while. So that's a square. I would definitely import math within the square root, because that's a way, but I'm pretty sure it was you down the coast that said we could do square root by doing this with 0.5, right? But anyway, we're talking about squaring, not square root. Okay, so our total here, oh, and by the way, we actually want to return the total down here. So we can't be overwriting the total, right? So I made a mistake. What should I call this something else? Maybe SQ total or squared total? All right, so now this is going to be the squared total. Add them together. That's what we're doing here. That's what this loop is doing, adding them together. So now we want to calculate the standard deviation. STDEV. And that's going to be the squared total. And we're going to divide that by the number, but I did forget one more step. And it was the step that you mentioned right at the beginning. It's the square root of the variance. So far, what we calculated here is the variance. So how do we get the standard deviation? That's where we do, like you said, we're going to import math up here, and we're going to take the math.sqrt of this number. And that should be the standard deviation. So we find all the deviations, that's the deviations, we squared them, we added them together, and then we divided by the total number, but I forgot that you also need to take the square root of that number. This is actually the variance, and then square root will give you the standard deviation.
You
Technically,
said that last line was the variance, or the second to last line?
this part right here, here, I'll highlight it.
I see it.
That part right there is the variance. The variance is this is describing the variance. You need to take the square root to get the standard deviation. All right, so how would I return that to the user?
Return stand def, just get that into the return line for tote mean.
Yep. So now,
Change that tote to square tote?
which tote? No, because that's why we changed this to square tote, because otherwise we'd be overriding it.
Oh, okay.
Because we still want the total. So now we get, I'll go back to the code in case anybody wants it. Now we get the total, 194. We get the mean, the mean, and the standard deviation. What's standard deviation measuring, by the way? I know this isn't a stats class, but anybody know? Somebody said the distance from the mean. That's pretty much the closest answer to what it is. So it's the average square distance. And that's what we calculated. The average square distance from the mean. The square root of the average square distance from the mean. So it's in the same units as the mean. So it's a measure of spread. How different the different values are. All right. So we could have another set of ages called ages 2 and have, actually, we could even show how, what if we had the exact same range? All right, now I'm going to run this guy. We've got the same exact range. Whoops, I'm not going to run it yet. I'm going to print the stats of ages 2, and we'll see how they're different. So in the first, oops, I forgot the second. There we go. Run. In the first one, the sums are different. In the first one, the average is 32. The second one, the average is 29. But look at how the standard deviation got smaller. Even though the range is the same in those sets of numbers, there's less variation. These numbers are almost all right around 25 and 23 and 26. But there's one older person. There's one that's 56. Whereas that's not so much of an outlier here. So that was printing the mean standard deviation. For those of you who are like really statistics nerds, technically the sample standard deviation would actually be mylist minus 1. The standard deviation is n minus 1, not n, unless it's a population, which most cases when you're calculating standard deviation, you're not calculating on the population, but I don't care whether you use n or n minus 1. If you wanted to do that, you could do something like that, and then you would get the true sample standard deviation. Either one's right for this, either one's fine for this program. But in order to finish this program, you do need to explicitly say which one of these, like you need to say the standard deviation, I mean, the sum is this, the standard deviation is this, and the mean is this. And you need to write that out and actually identify it. So that'll give you some practice with accessing these tuples by indexes. Now when I say tuples and lists are almost identical, you could actually return this as a list. And it would have functionally no difference. See, they're still lists. You could still access them the same exact way and everything, okay? So if you want to return them as lists, you can. If you want to return them as a tuple, you can. A tuple is technically slightly more efficient inside the computer's brain because they're not mutable.
So you're saying our output should be what we're looking at there, within the parentheses separated by commas. When you say sum is 194, mean is equal to 32, blah, 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 so on.
Yeah, I'm just testing your ability to index and pull out the individual values.
Yes, sir.
All right. So instead of printing, well, you could still print it, but it'd be much easier to assign it to a value, like output equals, and then break apart output to give you the results that you want. But, you could still do something like this. See, watch if I go 0 here. I'm just going to get rid of the second one here. You can stack these apart. See how when I run that, now I just get 194 because that's the first element of that output. So I could just put everything in a big print statement, but realize that when you do that, you're actually calling the function 3 times. If I did this and then I did the same thing 1 and the same thing 2, it's a little more inefficient. But
So what you were saying is we could create the output variable and then just print output with some characters. Is that what you were saying prior to this example?
yeah, I mean, I don't know exactly what you have in mind there, but yes, you take that output variable and you split it apart and you say the mean is, and then you put the mean, and you say the sum is, and you put the sum.
Yes, sir.
All right, so I'm going to save that. I'll upload that on GitHub, and you'll be all set. So that one is our one that we worked through 98% of it this week. Okay, so we won't work through the other ones quite as much, but we'll still tell you what you need and what you don't need. So the second one here is there's a function included with this lab. It's the one I brought up for a second. It uses a special module that allows it to request information from the internet. Okay, and it takes a city. Actually, it'll take any address you want to give it. So you could do your home address, and it goes out on the internet and uses Google servers to get a latitude and a longitude for that city or address. And then it returns it as a tuple. And so what I want you to do is modify the program from last week to take a short list of cities. So instead of the user entering a bunch of latitude and longitude values, take out the raw input and feed it a list of cities and have it calculate the distance to each city and the total distance overall. Okay? So it needs to report the distance along the path that it traverses. Okay? Traverses the entire list. Your list should include at least 5 cities. Just make them up, whatever cities you want. Okay, you just put them in there. And once you get that working, then you should move on to number 3. In number 3, you're going to take the script from here and modify it to include the script you wrote so that the user is also given the mean and the standard deviation of all the legs in this script. So it's kind of like a build-up. So once you do 2, then you'll do 3, and 3 will actually have everything inside it from 2. So don't kill 2, because 2 is, well, you, of course, you know what I'm saying, is you can say go ahead and save 2, but then start 3 by having 2 open and bring 1 into it. Because what you're going to do is find the mean and the standard deviation of all the legs. So how far was the average leg, and what was the standard deviation of all the legs? Okay. Let's look at this function and make sure that you know how to call it. Okay. So that is that's up here, and it's called well, the location.py is the function that gets a latitude and longitude from an address. Okay? And a simple example takes that's not it. I thought that was something that's not. Okay, so just copy and paste this code into Python. Into IDLE. So I'm gonna go ahead and file, save, and then file new file, and I'll call this one save as 3/2/2018. So this is an example, and all this does is this function finds it takes this address and it feeds it to this URL and gets the results and formats the results. You don't really have to know how this works. It formats the results and it returns a tuple. You can tell it returns a tuple right there. So if I actually go and run this, it's returning a tuple, and this is what Google says is the latitude and longitude for the city of Hattiesburg. Okay? And so all you need to do is, you change this to Jackson and run it again, and you can see if it works. Now you are limited to I think it's 1,000 or 2,000 requests a day. So don't yeah, Google will actually think that you're some sort of robot if you try to submit too many requests. Yeah. So one time we actually did hit the limit. I think because most of the requests are seen as the same from here. I mean, are seen as the same from the code. So. There was a class period where we messed up and all you have to do is wait till the next day. But anyway, that's how that works, and you can do any address you want. If we go back and look at the directions, what we want to do is basically merge that program from last week, and it's going to go through a list of cities. So the first thing that we could do here is just make it so that this takes a bunch of cities and gets the latitude and longitude for each one, right? So how could we create a list of cities? Let's do that first.
City list.
Yeah, in fact, I already created one, right? City list. I forgot which example that was in. Maybe it was in 2. I just love cutting and pasting. When I don't have to type. File, recent files, sample 5. Oh, there we go. Good. So there's my city list. You can copy mine or you can put in yours. Technically, there needs to be one more, but I'll put in one more once I get it working. In fact, you might want to narrow it down to just, you might want to leave it at 3, just for testing purposes, and then once you get it working, you can add the other 2. If you have at least 3, it's going to work. No matter if you have 10 or 11 or 12. If you only had 2, you could mess it up by just comparing the 2. Because you basically want to calculate the distance from here to here, and then again from here to here. So, and then the next one you'd go from there to there. Okay. So, how would I go about? One thing that I could do is there's a couple different ways to do this. One way is to go back into your program from last week that you wrote last week and just replace the times that you asked for X and Y. You could replace them with get address location and throw in the item on it. So you do a for statement. For, instead of having the while loop, you have a for loop and it loops through here. Okay? And then it pulls out each, it calculates the URL, the latitude and longitude for this one, and then it does the math it needs to do, then it calculates the latitude and longitude for this, and it goes on to the next one. Let's see if I still have that one up from last week. Recent files. So that was 2, 3, right? Let's see how far I got. I'm going to run this because I forgot from last week. 56. I guess I didn't get very far on that one. Yeah, I'm sorry. Yeah, that's right. I didn't even hook up point to distance in there. So hopefully you guys got a little bit further because I took distance out, right? So I think this will work now though. 45, 45. Yes, I want to keep going. Negative 10, negative 10. I'm in the southern hemisphere. Okay, so that's the difference. That's the distance along the globe from those 2 points. Okay. So yeah, this is working. Although it's saying point, and I told you to say latitude and longitude and stuff. So 30, negative 82. So that's the distance back to that one. So the total distance is 16,441 kilometers once I hit no. Okay? So what we need to do to get this to work is instead of this while statement, we need a for statement. So you would say, you copy your latitude and longitudes along with the rest of the other code, and you say for city and city list, do this. And then you have to delete the floating point. You have to delete the raw inputs. And instead, your x and your y's are going to be the output of this function. Your output here, the output of this function. So each time through the loop, you need to call this function, And then you need to get the x and the y value out. We can do that part together here real quick. So let's just, so this statement needs to be gone, and instead you need a statement like this. For city in city list. Make sure you got the capitals right. All right. So how do I change this so that get address location is not getting Jackson anymore, but it's going to get the first item, then the second item, and then the third item? How do I do that? So get address location, I want to change this to be the item each time through the loop. What is the item each time through the loop? What's it called?
Index.
The element, yes. So what's the label for the element each time through the loop that we've created? City, somebody said it.
Yeah.
Okay, good job. So you put city right there. So now the first time through the loop, city will equal Hattiesburg, Mississippi. The second time through the loop, city will equal Irvine, California. The third time through the loop, city will equal Calgary, Alberta. That's what that stands for. Okay. Now, this returns a tuple that has two numbers in it, and we want those to be called x and y, so we can actually, using tuple assignment, we can do this. Okay? If we wanted to be more verbose, I'm going to say get x and y using tuple and then I'm going to write this is equivalent. I'm going to say this is an equal statement because I can't spell. These are. So if we didn't have tuple assignment, we could go like this. Point equals this. And then how would I get x? X would be equal to point. It's the first item in it's a tuple, and the tuple has two things in it. So how do I get the first item in the tuple?
Point target 0.
Yes.
Target.
0, and y would be equal to point bracket 1. So this is a faster way to write this, but they're equivalent statements. Okay? So these are equivalent statements. This uses tuple assignment. This just references each of the values that's returned using their index. So I'm going to go ahead and comment this out because we don't need to do it twice. All right, so if I run this, well, here, let's print it. Print x comma y. If I run this, instead of just getting Hattiesburg, I get Hattiesburg, and then Irvine, and then Calgary. Okay? See, Calgary's way up north. You can tell it's way up north because it's got a 51. Okay?
Now, Dr. Rayburn,
Yeah.
could you tell it to print x comma y, comma like quote space dash space, and then whatever the name of the city would be?
Yeah. So like this, I could do city. That's what you're saying. City, comma x comma y. Like that? Is that what you were asking? Something like that?
Yes.
You could actually also print out, print city, and then you could print plus space like, I'm just getting a little more fancy, but it's the same thing. But now I'm, oops. Yes. Sorry. And your book even gets fancier in terms of string formatting, but we don't need to get fancy here. But you could, you can tell it. I was telling other students, you can tell it you only want to report 2 significant digits of a float, or 3 or 4 or 5. But so now I've got Hattiesburg, Mississippi. I've got the longitude and the latitude, and it's printed out as such.
Why did you have to make your last launch strings?
Because I can't add a string and a float together, like without Python. Because of the plus sign is ambiguous.
Okay.
For strings, plus means concatenate, and for float, plus means do addition. And so Python says pick one. You either need to change your strings to numbers, which you can't do because Hattiesburg, Mississippi isn't a number, or you need to turn your numbers into strings, so that I know whether to concatenate or to add.
Now, instead of converting each strings, could you say using the plus sign, use a comma, like print city, comma, and then quote bond, comma, with that, switching commas to plus and work?
Yes. So I could do this, is what you're saying. The difference there, and it's subtle, is that you're actually returning a very long tuple. Okay?
Okay.
So you're returning a tuple with 1, 2, 3, 4, 5. Well, you're printing a tuple with 5 elements. But functionally, it looks the same. You're right. So you can use commas. Yeah, exactly. So every comma will be printed as like a space, basically.
Before you did that, what did you put? Print city, X, comma, Y?
Yeah. So I was concatenating and using plus.
No, before that one too. The very first thing, you did something real simple. Print city, and I think you had X, comma, Y.
Oh yeah. Just print X, comma, Y.
Did you have anything after that? Because mine will not do it.
You need a comma after city too. Sorry,
Copy that.
I didn't say that off. So that looks like that. All the numbers are just pushed together with spaces in between. All right. So okay. So now what you need to do is we've got the X and the Y values. So we need to take all of this code basically. All this code. All of it, sorry, including all this stuff. Import math. Hold the shift key down. We need to copy that over into this code.
You said you copied that entire code set?
Yeah, I copied the whole thing. Okay. But I'm gonna paste it in here, and then in order just to like keep things a little more sane, first off, this is just an example. I'm just going to get rid of it. And I'm going to take all of the header stuff, all the functions that I built, and move them up. Whoops. Actually deleted instead of copying. I'm going to take all the headers and stuff, all the function definitions, and I'm going to move those up with all the rest of the functions. Now, I'm calling math twice here, math once here, math once here. It's okay if you do that. Python doesn't care, but I'm going to delete the other one just to be thorough. Okay? So now I have this function that I've written, and this is from last week. And so this loop right here actually needs to go away. And this is going to be the loop that controls everything. Okay? All right, I'll let you do that because it's almost done at this point, really.
Can you scroll back up to the top real quick?
Yeah.
I've kind of got lost on where you were pacing.
And as soon as class is over, I'll upload. all this to GitHub, so you'll be able to see this thing. But all I did was cut the code and paste it, and all these functions do stuff that, we don't really need to know what they do except for that they work. Next week, when we talk about modules, we can actually take all of these functions and put them in a whole separate file so that we don't have to worry about them anymore if we wanted to. We'll talk about how to do that. It's actually pretty easy. Whatever you want to name the file, my functions, you just create myfunctions.py, and then you can import my functions, and you can call these functions by saying myfunctions dot the name of the function in another file. Okay. So you can break your files apart and make them a little more organized. That's actually all math is. So math is just another. Math is just a whole another file that has a bunch of functions in it. All right. Okay, so yeah, this is like 90% done. You got to delete these x's. You'll need to keep first time and total distance, but you no longer need to keep going, because keep going is now it's not necessary, because you don't need to ask the user. So you need to get rid of all the raw inputs. So it's just going to run for each time through and report. Okay, so I'm going to leave that the way it is, and that's a pretty good start. If I put this up here, you should be able to get there. You're just going to delete a few lines of code and run it. I think, let me look at the assignment again. Yep.
You are recording this, right, Dr. Reverend?
Yes, I'm recording it.
You're my hero.
Yeah, the first part, my first class today, it didn't record, but you guys are the benefits of me messing up and fixing my problem. I guess I didn't have enough room because it just stopped about 2 minutes into the video. So luckily that one has a pretty verbose slide show presentation. But all right, so once you get that done, then you can modify the script from above to include the function you wrote, so that the user is also given the mean and the standard deviation of all the legs. Now, this one, let's talk about approach a little bit. Because one thing that you could do, although it would involve almost totally rewriting how you did everything, is that you could actually have it calculating the mean as a run every time running through. But that's not the way your function's written. Your function takes a list, right? It takes a list, and then that list it calculates the mean and the standard deviation on. So in order to write 3, it's going to be much easier for you to use the existing function if you build a list as number 2 is executing. If you build a list of all of the individual distances, and then take that list and call your function at the end. It's going to be easier than trying to put standard deviation and mean and total, which you're already calculating total, but calculating mean and standard deviation inside of your current loop. You could do it, but it's going to involve rewriting some code. So it's going to be easier for you, and it's the way that I want you to do it, is to just build a list inside of the program you're already written. So let's look at the code right here. So you're already calculating the current distance. That's the leg through. So what you need to do is, outside of the loop, create a brand new list, and then each time through the loop, put this number inside of that loop. The cdist number inside of the loop. And then at the end of the loop, after the loop is done running, you can feed in the list you created into the function that you created, or the function we already wrote it. We already did 99% of it. You need to call that function, and then you'll get the mean. You'll get the total again. You'll get the total again, which will be fine. In fact, you could get rid of the other total just to make, not get rid of it, but just don't report it anymore here. And then you'll get the total length, you'll get the average length, and you'll get the standard deviation of the lengths. Kind of like the showing you the spread of the trips. Okay? On average, your trips are about this long, but some of them could be really, really long, and some of them could be really short. That's what will happen if you have a high standard deviation. Or they're all about the same length. That's what happens if you have a low standard deviation. Okay. That's the way you interpret the standard deviation. Okay, so yeah, it's a little bit later than we normally like to finish the formal part, but I'll be around for a little while to help you through this or any of the other issues. Did I finish everything that you wanted to ask me about the previous one, or did you have some more questions at the very beginning of the class I was talking about last week a bit?
Actually, I saw the log through. I was curious about calling the function, but seeing some of the work you've done today, I got it squared away.
Okay, great. I'm going to stop this recording right now so that I can get it up there, and the recording will be up there, and as well as all the code that we've talked about.